so let's move on. A spring can do work, and it can do work after we put what into it? Energy, right? So we do work on the spring, we store energy in it. It's not gravitational potential energy now, it's elastic potential, right? Because it's stored in an elastic object. And then we can release that, and the spring can do work on an object, in this case, this ball. So what happens to that elastic potential energy? What does it become? In this example.
Kinetic energy.
Kinetic energy of the ball. Right on, Ryan. The equation to get the potential energy of an object, elastic potential, is 1/2 kx squared. Now in chapter 10 and 11, we worked with this equation. Hopefully you recognize it. Right, conservation of mechanical energy. Well, this elastic potential energy is a form of mechanical energy, so now we can actually add this new form of energy into this equation, right? So now you see mass won't cancel out anymore, right? Mass is not part of this, but so it doesn't cancel out, so that's why we need to leave mass in there. But now the sum of all the initial energies equals the sum of all the final, okay? So in this problem, it's all in one plane, right? It's all horizontal. So the height doesn't change, right? So the potential does not change. So the initial height and the final height are equal. So those terms are the same. So they subtract out.
Is the initial velocity zero?
The initial velocity is zero, right? Because I'm going to compress it and hold it in place. So it starts from zero velocity. So there's no kinetic energy initially. So what you have is that the initial elastic potential equals, now what happens to this one?
Zero.
Right, zero, right? Once the spring is back to its original length, there's no potential energy stored in it. So the initial elastic becomes the final kinetic. So that's what you have there. So the halves cancel. So it's just K is 80. And it's compressed 2 centimeters, so that's 0.02 meters, equals the mass 0.5 VF squared, so VF is 0.25 meters per second. Okay, so this is the equilibrium point. This is where x equals 0. Okay? This is 0.100 meters below that. So what happens? We compress it. We let go. The spring springs up. It comes back to its original length, which is the equilibrium point. The block keeps going because it has the energy to keep going. And then it goes to the maximum height. The spring stays here. So let's look at what's happening here. Initially, it's at rest, right? So V is 0. So that means the initial kinetic energy is 0. So that's that term. The spring is compressed 0.100 meters. So there is elastic potential. That's going to be equal to 1/2 K is 5,000. And X is negative 0.100, squaring it. What you want to know is the height above this level, right? So there is actually negative potential energy relative to this level. So then you got to do the mass and negative 0.100 for your initial potential. And now, once this happens, at this point, XF is now 0, right, because it's back to equilibrium. What you want to know is when things are going on here. So here, VF is 0. So there's no kinetic at the end, so that's gone. And because xf is 0, the displacement of the spring is 0, there's no elastic potential. So the spring's elastic potential plus the negative potential energy it had, gravitational, equals the final gravitational potential. So you got HF. So HF is 10.1 meters. If you didn't take account this and you just said that elastic potential becomes final gravitational, that is true, but that would be relative to this point. So you would have gotten 10.2, but it would have been 10.2 above here, which means it's only 10.1 above the point we're asking about.
I don't know what I did.
So let's visualize we have our spring and mass system, and our mass is oscillating back and forth. So it's doing this back and forth, right? Sometimes it's over here, sometimes it's over here, and then at other times it's in between. So it's going back and forth, back and forth. When is the magnitude of the acceleration maximum of the velocity, the maximum, and the force, a maximum. Just think that over and then I'm going to talk about it.
I think the acceleration is like right as it starts going off, like, at the one direction. Either way, like when it's like going, when it's changing direction.
So either here or here?
Yeah.
So you're saying acceleration is a maximum either here or here?
Correct.
Okay. You agree? Okay. Alex?
I think the force is also at a max in those two spots too.
So force is max. That makes sense, right? Because force causes acceleration. So if force is high, acceleration is high. Jeff?
Velocity in the middle.
Velocity is the max here. This is correct. Good job. Now, the force is a maximum in the ends because wherever there's maximum x, right, there's maximum force. So that means that there's maximum compression, there's maximum extension, so you have maximum force. Wherever the maximum force is the maximum acceleration, right? So that's because that force causes acceleration. And this is correct because once it gets to either side of this point, right, the restoring force kicks in to slow it down, right? So that means, so from here to here, it's accelerated up to this point, and then it begins to slow down. So that means it's moving as fast as at the middle, at equilibrium point. The displacement is a term we've been using since yesterday, but we know what it means. It's the distance of the mass from equilibrium at any point. Very good. Right, so the amplitude is the greatest distance from the equilibrium point. So your maximum displacement is your amplitude. A cycle is a complete back and forth motion. So from A to negative A to A, or from negative A to A to negative A, whatever, one complete motion is considered a cycle. The period capital T, the time required for one complete cycle. And frequency, lowercase f, the number of cycles per second, measured in hertz. The period and frequency are inversely related. So if the frequency were 5 cycles per second, so 5 hertz, what would the period be? 1/5, right? The period would be 1/5. If the 5 cycles per second, it would take 1/5 of a second for one cycle. So you can remember it that way or just use those equations. It's one over the other is the inverse.